Please do confirm.
Yes, sir.
Okay. I think recording. Okay. Yeah. So before I start with the day one, right? So I somebody else is joining. Okay. Let's start. Okay. Let us start with the day one. Okay. So basically, before like I proceed further with the day one, so I was thinking to have it as an interactive way. Okay. So initially, I will just finish all the course materials where we have to we have to cover most of the parts which is already given in your syllabus, right? So we will cover that and we will have the interaction way, so that like, so based on my experience on the industries where I implement the latest technologies, the cloud, AI, and also these smart technologies, right? So we'll have an interaction, the calls where you guys will ask some questions, or like I will ask the questions, and we can able to understand each other what exactly happening in the industry. So basically, I want you guys to know what exactly is happening in the current market, right? And what are the technologies and how you can able to implement that in your current organization, or like anything, right? So that is what I was thinking. And while we talk about these slides, I will talk about the AWS cloud, IoT, building management systems, and intrusion systems, and so on. Okay. So let's start with smart grid, right? So today we'll talk about the architecture principle of you know uh, the smart grids, and why we are using it, and so on, right? So now, so the smart grid, if you see the legacy smart grid, right? So if you see here in the left hand side, so it's all about, initially we have the power plants. So the power plants can be in the coal or the nuclear and hydro. So if you see, the legacy always flow from the power plant to the consumers, and it is connected through the substations and then lines, and it's an obvious, right? And the consumers have very little interaction with the plant. The problem here is, one is the unidirectional. Yes, it is only the power only flows from the power stations to the consumers, and it is centralized. So we only have the main source of power is the coal, nuclear, or hydro. So when it comes to the monitoring, everything is in manual monitoring. So there is no automation, nothing. And also the maintenance is reactive. So basically, if something breaks in any of the part, let it be in the power plant, or anything in the transmission lines or distributions, so that everything is reactive, it is not an proactive. So if it is reactive, only once the system is broken, then only we will be fixing that, right? It is not we will predict that and then mitigate those problems. And the visibility, so visibility in terms of fault, can it be occur or not occur? So this visibility, it is not that much good in the legacy. So what are the drivers? So when I say the drivers, what is making us to move towards the smart grid, right? Hold on. Okay. Yeah. Okay, when I say the drivers, so these are all the drivers. So one is the aging infrastructure. So if you see the infrastructure, what we have, the power plants or the distribution or the power, it's all the aging, and also we need the increase of the electricity has been very gone up, right? So the consumption has been increased, and we have this. The demand increasing, so that we are looking for an alternative, right? Such as integration of renewable resources like the solar, the winds, because the many investors are investing on the solar and also the wind, and the grid reliability issues and the blackouts, right? So also we need some efficiency and decarbonization. So when it comes to the regulatory, so the Indian government or any of the subsidiaries, they are making it mandatory, telling that the carbon footprints, whatever we are generating through the coal, and it could be a nuclear, right? It has to be reduced significantly in the further years, right? So that is one thing. So these parameters. One is the aging, the other one is decarbonization, and the regulatory and sustainability. So sustainability is like when we invest on something, it has to come it has to operate for the many years, right? So these the drivers are making us to move towards the smart grids. So in the smart grids, if you see the legacy and the smart grids, it's all about, in the smart grids it's all about the bidirectional power. It's all about the bidirectional power and data. It is not only the power, right? It is all about the power and the data. Here we are uh, not only the consuming the power, we also distributing the power, and also the we are distributing the data between everything. So let's say we are taking the data from the windmill, we also taking the data from the solar energy, and we also taking the data from the household who are consuming this energy, right? And everything is happening in the real time. So let's say uh, if hold on, somebody else is joining. Okay, I think he has joined. Right. So the monitoring is at a real time, and everything is automated, right? And what we are going to achieve is the resiliency. So if you see the meaning of resiliency is like, it is not, we are not depending upon the any single source now. So we are depending on the multiple source. If something breaks, let's say the solar system, it is getting break, then we are not only relying on the solar system, because everything is interconnected, and we can able to draw the power from the wind, or else for power from the nuclear or hydropower, so that the consumer will not face any the blackouts, right? So this is what the legacy and the smart grid is all about. This is just an introduction. Once we move into the more course details, you will have the more technical details, right? Anyone have any questions here? All good?
Yes.
Okay, so let's move to the next one. S- Okay, let me reshare my content. Okay, so let's say now let's talk about you know how do we define the smart grid ecosystem, right? So here, if you see, to make any system a smart grid, right, we need three components, right? We already have the power infrastructure, and on top of that we need the digital communication, and then automation and the control. When you just have these three main important components, then we can able to create one smart grid. So when somebody asks you what is the definition of the smart grid, so it's all about the electric network that uses the digital communication, the automation and the control technologies, right? So that we can able to enable the bidirectional power power flow and also the data flow, right? So the key objective here is to achieve the reliability and resiliency. So when we have this two important objectives where reliability and the resiliency is achieved, the complete system will become the self healing capability. So when we say self healing, so system can able to detect the fault, right? If something fail in any of the one of the component, system can able to trigger the alarm, and immediately we or else we can able to automate the system so that it can heal itself, right? And also when we have the resilient and the reliable system, we always have the minimum downtime, right? So that is one thing. And then yes, we when we have these objectives achieved, we also increases the efficiency. So basically we increase the efficiency of the assets, right? And also we can able to reduce the losses. And yes, the sustainability. So here we are enabling the distributed renewable energy source, because we are not relying on any single source, right? We are not relying on only the coal or else hydro or else the nuclear. We are integrating the complete system, solar system, wind system, any other means of energy generation into this, so that it will be a distributed energy source. It is not a single source. So when we have all these combined and when these systems are talking to each other, we can able to balance the demand and generation. So this is all about the objective of the smart grid ecosystem, right?
Sir, screen is not visible.
Screen is not visible, huh?
Sir.
Okay, hold on. Okay, ಫಸ್ಟ್ ಇಂದನೂ ವಿಸಿಬಲ್ ಇರಲಿಲ್ವಾ ಅಥವಾ ಇವಾಗ ವಿಸಿಬಲ್ ಇಲ್ವಾ?
Just now.
Just now, huh?
Yes.
Okay. Let me reshare my screen. So ಇವಾಗ ಸ್ಕ್ರೀನ್ ವಿಸಿಬಲ್ ಇದೆಯಾ? Can you please
Okay.
confirm? Visible ಇದೆಯಾ?
Yes, sir.
Okay, great. So I think we have a couple of more participants. Hi Salman.
Hi,
Hi
sir.
Pavan. Okay.
Hi, sir. Good morning, sir. Madhu, sir.
Oh sir, good morning. How are you? Good sir.
So early already class started.
ಹಾ ಸರ್ 7ಗೆ ಸ್ಟಾರ್ಟ್ ಮಾಡಾಗಿದೆ. ಸೊ ಐ ಥಿಂಕ್
Okay.
ವಿ ಹ್ಯಾವ್ ಅ ಪಾರ್ಟಿಸಿಪೆಂಟ್ಸ್. ಸೊ ಐ ಆಮ್ ನಾಟ್
Sir,
ಶೋರ್ ಲೈಕ್.
total 8 members ಇದ್ದಾರೆ.
ಓಕೆ
ಟೋಟಲ್ 8 members ಇದ್ದಾರೆ ಸರ್. ಜಾಯಿನ್ ಆಗ್ಲೇಬೇಕು.
ಓಕೆ
ಆಮೇಲೆ ಇಂಟರಾಕ್ಟಿವ್ ಸೆಷನ್ಸ್ ಅವಾಗ ಅವಾಗ ಮಾತಾಡಿಸ್ತೀರಿ. ಅವಾಗ ಸ್ವಲ್ಪ ಡೌಟ್ಸ್ ಗಳೆಲ್ಲ ಕ್ಲಿಯರ್ ಆಗ್ತಾವ ಅವರಿಗೂ ಸರ್.
ಕರೆಕ್ಟ್ ಫಾರ್ ಶೋರ್.
ಸೊ ಎಲ್ಲರೂ ಇವರು ಮಧು ಸರ್ ಅಂತಂದು. ಸೊ ಥರ್ಡ್ ಮಾಡಲ್ ಇವರೇ ಕಂಪ್ಲೀಟ್ ಮಾಡೋದು. ಸೊ ಏನೇ ಡೌಟ್ಸ್ ಇದ್ರು ಇವಾಗಿನೇ ಕರೆಕ್ಟಾಗಿ ಕೇಳ್ರಪ್ಪ.
Sir.
ಅವಾಗ ಅವಾಗ ಅವ್ರನ್ನೂ ಮಾತಾಡಿಸ್ತೀರಿ ಸರ್.
ಶೋರ್ ಫಾರ್ ಶೋರ್. ಥ್ಯಾಂಕ್
ಓಕೆ
ಯು ಸರ್,
ಓಕೆ ಸರ್.
ಥ್ಯಾಂಕ್ ಯು.
ಓಕೆ.
ಓಕೆ. So yeah, sorry, like it was not visible that time. So this is what the architecture what I was explaining. So basically the smart grid, we have to have the digital communication, the automation and the power infrastructure, right? Okay. Yeah. So coming to the architecture stack. So let's say whenever we design a system, right? So we need to have some architecture point. So for example now, so if you see here, there is important 6 layers. One is the physical layer, and second one is sensing and the measurements, and the third one is the communication. So these three, what we call it as an edge. So where the physical and the data transport will happen, right? Basically, first three layers and the last four layers, like uh, uh, hold on. Who is joining? Hi Rashmi, and who else joined? Okay. Okay. And one request. So from tomorrow onwards, can we please join around 7 or 7:10 so that we can start on time? Okay, fine. So
Okay.
I was explaining about these architecture stacks, right? So yeah, and the last three stacks, that is the layer 4, layer 5, and layer 6, it's all about the logical discussions and the logical computations, right? So in the layer 4 we have the control and automations, where we have the systems like the SCADA, EMS, and a DMS, DRA. So these system will help us to build the logical, basically. So we will be going in the depth in the next couple of slides. Okay, this is just an introduction about the architecture stacks. So these the system will help us in pushing the data which we have collected in the edge, that is in the physical and the data layer, and these data which are going to push from the SCADA system will be forecasted. I mean, like by using the latest uh, the models, that is the artificial or like machine learning models, we will be cleaning the data, we will be processing those data, and then we will be having one good insight. So what exactly the demand response is, what is happening in the system, and which specific time duration the demand was very high, and where exactly the fault is happening, and what was the effect because of the fault, right? So this is what the layer 5 is all about, and the layer 6, it's all about taking the decisions, right? So from the in the layer 5 we already did the analysis, and based on the results what we got it from the layer 5, we will be taking the decisions in the layer 6. That is all about how much will be, either it could be an reactive or proactive, right? So telling that how was the billing the last month, and what could be the billing, so predicting the future billing, and how was my system the last month was, and how my system will behave in the next month. So and also we can able to predict the trading, right? So if we are trading the energy to any other state or any other country, so we can able to predict, okay, the last month or last year, this is what uh, the demand was, and the next year this is what the demand, and that could be very precise decision, right? So this is the architecture stack we are having, the 6 layer architecture stacks. So coming to the, the layer 1, that is the physical layer, right? So in the physical layer, yes, we have this okay. So in the physical layer, we can have this power generation units, that could be an coal or else the nuclear, hydro. So it could be in any generation, right? And that generation, it is connected to the transmission, and this is all about the physical layer, right? The transmission lines, the substations, and distribution feeders, and it also includes the load. When we say the load, it could be an residential, it could be an commercial, and also the industrial one, right? So these are all the physical layers, and this is kind of part of the legacy infrastructure also, right? Now, so how do you make this the power physical power system into the smart grid? So we need to have some conversion of this the analog parameters, right? So to do the converting this analog parameters into the digital, we use the sensing and the measurements. So we have hardwares. Let's say in the layer 2 we have the sensing and measurements. So here we have the sensors. So so we have the smart meters, which in 24 by 7 it will be monitoring the voltage and also the current and also the frequency, and these will give the parameters like the power quality, so that we can able to monitor those, right? And also we have the PMUs, that is the phasor measurement units, that it always keep on measuring the phase differences, right? So that is one thing. And coming to the functionality, yes, as I mentioned, it captures the voltage, the current, the frequency, and the power quality. So basically, we are trying to convert these analog, the parameters which is in the physical layer, into the digital. Correct. Here we are trying to capture the parameters by using the smart meters. So let now we have connected this physical layer to the smart grid. Now, how are you going to communicate this data which is generated in this digital meter? So, basically, in the layer 3, it's all about the communication, right? So, let's say now, so we have basically two means of taking the data out of these meters, right? Let's say we have an wired and the wireless. So, for example, the wired, we have RJ45, right? So, RJ45 cable is the one of the physical, the wired medium where we can able to utilize that cable for up to 90 meters only. So, let's say you have very small communication the distance, so you can able to utilize that RJ45 the cable, but we can able to only send the data up to 10 Gbps. And also if it is not 10, it is less than 1 Gbps. But let's say if the distance is more than 100 meters, the plant is very much big, then we cannot use the RJ45 jack because it's in copper, and for that we have to use the fiber one. So in the fiber we have the two types. One is the single mode, other one is the multi-mode fibers. In the single mode fibers we can go up to 10 kilometers of the range. So our plant is basically and very big, it could be a solar plant, and it has spread across the acres, right? And if you want to communicate all these smart sensing devices, so we have to use the fiber. So if let's say like if you have the 2 kilometers or 3 kilometers wind range, you have to use the single mode, that is OS2. That is what we call an OS2. And if it is less than 500 meters, we can able to utilize the multi-mode fibers. So multi-mode fiber is for the shorter distance, and single mode fiber is for longer distance. And also the single mode fiber, we the data carried, it will be very less compared to the multi-mode, right? So this is the one thing. And let's say for example you cannot lay the cable, like RJ45 cable or else the fiber cable, it could be in various terrain conditions. You cannot be able to the lay the cable. So how do you do that? So in that case we can utilize the wireless technologies. You might have been heard about RF, the messing, correct? So basically this is similar to the Wi-Fi. So, but instead of the indoor bandwidth or else that specific range, we are utilizing the outdoor wavelength, right? And here in this, we are utilizing uh, the Wi-Fi. So basically, it is similar to the Wi-Fi only, but the structure and the design components will be differ. And these we can able to mount it in a different locations, and these Wi-Fi points can able to talk to each other, and all those can able to send the data to the specific locations. Like we have SCADA system, so basically centralized monitoring locations. These the communication can happen. And also if we are not allowed to use to install the Wi-Fi, then we can able to go with an LTE or else 5G. We can approach any of the providers. So we have a number of providers like LTE or the 5G. So if we have the agreement with those the providers, they will allocate one small spectrum to us, so that we can able to utilize our routers and the Wi-Fi broadcasters, and then we can able to communicate within that same vicinity, right? And the Wi-Sun is the, like, latest open source protocol. Even this we can able to use it, but because it's like more tedious to configure, so we don't use much. It has not been adopted that much. So the most adopted technologies RF mesh for the wireless, and the wired it is OM3 or else OS2. So this is what the communication uh, the part. And the protocols what we are using is either the Modbus is very famous one, and the DNP3 and IEC the protocols, right? So this is all about the layers, layer 1, layer 2, and the layer 3 one. So anybody has any questions? Anybody has any questions? No questions? So you guys has to speak up. ಎಲ್ರಿಗೂ ನಿದ್ದೆ ಬರ್ತಾ ಇದೆಯಾ?
No, sir, no.
ಓಕೆ. ಸೊ ದ ಫಾಸ್ಟ್ ಹೋಗ್ತಾ ಇದೆಯಾ ಅಥವಾ ಇಸ್ ಇಟ್ ಓಕೆ? ಇನ್ ದ ಪೇಸ್ ಓಕೆನಾ ಅಥವಾ ಇನ್ನೂ ಡೀಟೇಲ್ ಆಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಬೇಕಾ? ಐ ವಾಂಟ್ ದ ಫೀಡ್ಬ್ಯಾಕ್ ಅಟ್ ದಿಸ್ ಪಾಯಿಂಟ್.
No, sir, it is correct. No issues.
No issues, sir. So others? So we got a new joinee ಅಲ್ಲ? So who was that? The Sneha ಇತ್ತಲ್ಲ. So who joined lately? I think somebody joined around 7:30. Who was that? Rashmi, correct? Hello, Rashmi. Okay, whatever. Fine. Okay. So let's move to the layer 4 in our architecture, right? So in the layer 4, it's all about the control and automation. Let's say in the in that layer 3, we already collected the data using the media. It could be unwired or wireless based on these protocols. This is the communication, the protocols, right? So now we just have to dump that data somewhere. So the data, so where we are dumping it, either it could be in the SCADA system. In the SCADA system, we'll be having the database, right? In the database, all the data, that is the real-time data, will be stored and it will be processed, right? It could be in SCADA or else the energy management tools. There are various energy management tools which is provided by, let's say, for example, we have an ABB, we have a Snyder. So these companies, they have their own energy management tools. Even Johnson and Johnson Controls, they have their own tools. What they will do is, so once we gather all the information, they will store it in one of the database, and then they will be processing it, right? So let's say, uh, for example, the last day, what was the voltage level, or the what was the power consumed, how was the all sensor was behaving, and the complete information, it will be processed in this specific system, Right. The SCADA system, it's an architecture and the software which will be installed in one of the server. So when I say the server, so it is kind of the bigger version of our the computer. So these requires bigger the power consumption, and it has the bigger CPUs, bigger memory, and it will be running on a latest OS hypervisors, what we call, with the virtual machines. So these servers will be installed within the either it could be an same generation facility, or else we can able to install these servers in one of the data center also, so that uh, the all the data will be dumped in these servers and the processed. It could be in remote processing or else on premises processing. And coming to the latest technology, so this SCADA system and EMS system nowadays, it is not hosted in the data centers, so completely it is hosted in the AWS or else Azure. So these are all the cloud providers. So we have let's say for example, let your management decides you don't want to invest on the on-premises hardware because the servers are very costly, right? So let's say they said, okay, we don't want to invest on these hardwares because the maintenance required some certain level of skills, and also you need to hire someone to maintain that, to configure that and everything. And if something breaks, the the technology guy has to move to that specific location, do the configurations. So instead of that, what the current technology is having is every these system are being hosted in the AWS. So in the AWS, so same system will be hosted, and all the data what we are fetching right from this communication, so everything will be processed in the AWS. So how the communication will happen? So basically on premises we will be having one router, right? And from the router we will configure an IP address so that it will reach to the specific cloud or else the data centers. From there we will implement the SCADA system with certain algorithms, and based on the algorithms, so it will give us the insights. So now in the layer 4 it is all about the control and automation, and the good part here is everything is happening in the real time. It is not the historical data. Anybody has any questions?
ನಾನು ಸರ್ದಿ ಕೇಳಿದ
Can you go on a mute? Okay. So yeah, this is all about the layer 4. And now we have collected the data. So now we have the data within the SCADA system where we have the database, correct? Now, after this, the data which is in the database will be processed, and we will get an insights. So what kind of insights? So we get the load forecasting, outage management, the predictive maintenance. So everything will be processed by using the AI and ML based optimization, right? So when we have these forecasts, right? So load forecasting, outage, the management, and everything. So we'll be having the decision making will be very much easy, right? So in the layer 5, it is all about the application and analytics. And in the layer 6, it's all about the enterprise and the market. So based on these insights, the business team will take whether they have to increase the production or decrease the production, or they have to maintain certain uh, sensors or so on. So it's all about the regulatory reporting and the so on. So this is all about the 6 layers of the smart grid technologies. Yeah. So anyone having any questions here? No questions? Okay, great. Yeah, we'll do one thing. Before we move to the next section, we'll take a short break, okay, for a 5 minutes break. We'll come back at 7:55. That should be okay, right?
Sure.
Sorry, Pawan?
Okay, sir. Sure.
Yeah, yeah. Thank you. Okay, shall we proceed? I think many hair left. Okay, let's start. Okay, so is my screen visible?
Yes.
Okay, great. So now we spoke about the layers of smart grid technology, right? Let's say now we will discuss about the real-time visibility. So basically the eye of the grid. So I know everybody know these components, right? So without these components, we cannot measure the parameters like the voltage, the current, and other parameters like the temperatures and so on. So without these, sorry, these devices, so it is very much difficult for us to measure the parameters and convert that analog into the digital. So let's say now, so the key components, we can say the key components and the roles. So basically, what we are having is like, so we have the common sensors type. It could be an the voltage sensors, and it can be in CTs, that is the current transformers, and the sensors. So these temperature sensors will be mounted inside either the transformers or else any of the HT and LT panels, right? So the this is the very critical, because the most of the time the breakages of the system will happen because of that increase in the temperature. So when we regulate this temperature and at a certain uh, less than the specified or else threshold level, if we identify this temperature, we can able to mitigate most of the accidents, right? So this is where the critical the sensor is. And then also we have the frequency sensors and the power sensors. The power quality sensors are like, so we have an harmonics, right? So harmonics is like unwanted frequency which will be induced inside the system. Because of the harmonics, there are a lot of accuracy going down, so we just have to mitigate those harmonics. So basically how do we do that? So we can able to implement the certain level of filters, right? So we'll see in the further details how we can able to move that. So these are all just an introduction for this the smart grid, right? And also we other part is like flickering. So how, like if we measure that harmonics, the flickering, the temperature, the frequency, everything, so these are all the key parameters is what we need to make the complete system as an intelligent system, right? So now we have these parameters, right? So now the technical characteristics, how are we going to take this analog signal and convert that to the digital signal? So we have the sampling technologies, and let's say so we cannot take complete analog signals from these devices, right? So we have to do the sampling. So the how accurately we are doing the sampling, that results in the better output. So that is what the sampling. And also we are using the time synchronization, that is like GPS based PMUs, or else edge intelligence. So this is like where the new technologies comes into the picture, where we are processing these datas, these sensor datas at the edge in the sense at the perimeter level. So these the processing will be happening in the substation level. Let's say in this inside the substations we will be having small data centers where we will be having the servers, right? So these servers will collect all these parameters, and these parameters will be processed within the edge. So that is the name they have been given as an edge intelligence. Everything process will be happening within the perimeter, that is in the substation level. From that, process data will be pushed to the main data centers. So once once the data center is pushed, the data is pushed to the data center, further action will be taken in the data center. So this is the latest the trend which is happening. So not all these parameters will be sending to the data center. That is the key point here. Only the processed data from the edge location will be sending to the main data center, right? And yes, the security is very much is needed, because we initially in the legacy system, everything was an analog, right? And it was the manual. And if something, the if you want to operate any breaker, we will be having the circuit breakers, right? If you want to operate that, the manual, the way it was, so somebody has to go there and pull the lever and has to break the system. Now the trend has been changed, it's all about the digital, right? So within, from the command center, within the substation, we can able to on or off these circuit breakers. So hold on, echo, pause. Right. So when we convert this analog to digital, there is lot of problems analyzing arising. Right. It could be in cyber security, because anybody can able to capture those packets. So when I say the packets, so when we convert this analog into the digital, right? So we are converting these analog parameters into digital, and this makes the anybody which who is having the computer can able to grab that. From, if we are transmitting these data through the wi-fi, then it is very much easy, so that anybody can able to grab that packets and process it. Or else there is other kind of securities like DDoS attacks, you might be heard, right? So just keep on sending the packets to the data center, so that it is in denial of service. So actual the service which is required, let's say the SCADA system is connected to the data centers. So if some attacker is continuously sending the packets instead of actual packets, these are the actual packets is what we need. So in that case, it will be completely a denial of service, right? So the securing these parameters is very much needed. And we will see how we can able to secure our digital, the parameters here, right? And what the coming to the impacts, so when we have these sensors, what we can able to achieve is, one is the early fault detection, right? So when we have these parameters, we can able to predict how the system behavior will be for next day or next week or something, right? And when we have this early fault detection, so we can able to improve the grid stability. So when I say the grid stability, so we can able to detect the fault, mitigate that, and less the blackouts, and the less service interruption, and so on. So basically, we are developing an the self-healing grid for an automated system. So that is all about uh, you know smart grids, and these are all the very important the components of the smart grids, that is sensors and their roles, right? Yeah. Yes. So anyone having any questions on this specific part, key sensors? Okay. Yeah, moving on to this intelligent the bridge to the customer. So let's say now we were talking about making the system complete system. It could be an generation station and the consumers, right? We spoke about how we are trying to merge these and making the system as an intelligent one. So how do you do that? So the question is like, so do we have to introduce any new meters? Then answer would be yes. So we have to introduce the smart meters. So So we have so AMI. So this is the smart meters. So what this will do is this will act as a bridge between the utility. So it could be an BESCOM, MESCOM, any of the electrical service provider, right? And the consumer, it could be an home, it could be an industrial facility, or any of the consumers. So basically, the core function of these smart meters, let's say what it will do is it will measure the energy consumption in real time. That is the very important one. So it is not like every one day it will collect the data, or else every week. It is not scheduled like that. So every minute, every seconds, all the data which has been consumed in the consumer side, it will be recorded in the smart meters. So, and these the recorded data will be sent to the our processing unit, that is our SCADA system, or else like this data can be sent to this the BESCOM. From the BESCOM, they are going to send to their remote data centers to process the data. So this could be an either way, right? And the second point is two-way communication now. So consumer can able to pull the data about the production of the energy resource here, and also these utilities, that is the electrical providers, can able to pull the data on the consumer side. So it is like in bi-direction two-way communication now. So even the consumer will have the visibility about the production, and the electrical service provider will have the visibility of the consumer side, right? And once we have this data, real time data, so we the utility, or is like the electrical service provider, can able to remotely connect or disconnect, and also he can able to give the time of usage, right? We call it as TOU, pricing support. For example, so electrical supplier will have the surplus energy. So at a specific duration of time, they are generating more energy, right? Instead of giving in the same tariff, they can able to offer the electricity on the lesser tariffs, because we know this demand based on the smart meters. So when we do that, so even the consumer will be happy, telling that on the specific duration of the time, or like any specific time, they are getting the cheaper pricing on the electricity, right? And so this is how the two-way communication will happening. And so basically it is in the phase of implementing. If you see any of the developed countries, right, this is already happening it, right? And coming to the technical capabilities, right? So this is all about the core functionality about this intelligent smart meter. And coming to the technical capabilities, so what we can able to do is, so we can able to configure these smart meters, telling that every 15 minutes we can able to record the either the consumption or else the utility, right? So we can able to configure 1 minute also. So based on our requirement, we can able to configure what exactly we need. For example, we are taking as in 15 minutes. And coming to the security, let's say this smart meter always converts the analog signal into the digital. Now digital, how we are going to make sure my digital parameters are safe. So one way of doing is the encryption. So how the encryption, so encryption will happen in the two ways. So basically we'll be having the public key and private key for the encryption. So based on these two keys, we are going to encrypt the data which is present in the smart meters, right? So when we encrypt these data, if somebody from the outsider, if we able to get into this system and can able to pull the data, even though if he pulls the data from these smart meters, it is encrypted. He cannot do that, or he cannot fetch any of the information. Let's say these smart meters will have the information about the consumers, consumer name, consumer like address, consumer like phone numbers, or it could be anything, the personal information. So if someone able to hack into the system and get these data out, then he can able to sell those to the unwanted people, right? So to avoid that, what we will be doing is, one is encryption, right? So other one is the authentication. If someone wants to log into this smart meters, they have to authenticate themselves. It could be an OTP based, or it could be an the password, or it could be an biometric, and these kind of, the authentication is what we are implementing in the smart meters, so that these smart meters are secured, right? And the third part is like the firmware. So let's say now the we are secure the data here inside the smart meters. So when we are sending the data outside of the smart meters, so we call it as in the over the air, or else like the data at the transmission. So here also we are doing the same thing. So we are using the firmware, and we are encrypting the data once again, or else we can encrypt the same data securely. So basically we will be creating a secure connection between these smart meter and the utilities, right? So this is how we can able to establish the very secure connection between the consumers and the smart meters, and from smart meters to the utility. So let's say, coming to the events, uh, let's say if someone trying to hamper this the smart meters, so these smart meters, what it will do is, so these, it will send the data, or else this will send the notification to the specific provider, telling that these smart meters have been hacked, or it has been trying to breach. And based on the logs which has been logged inside these smart meters, the required necessary action will be taken, right? This is what the technical capabilities, what the uh, smart meters is having, correct? And the coming to the integration part, so what this will do is, this will integrate with the head end system. So when we say head end systems, I was talking about this, the main utilities. So it could be, let's take an example of the Bescom. So Bescom is an head end system for us. So these are all the tail end for now. So what we will be doing is, so all the meter data management which will be here, and this will be processed within the head-end system. And based on this consumption from these smart meters, the consumers will be built, and also the analysis will be taken care on this. So this is how we are making the system completely completely smart, right? So this is how we can able to predict the system. This is where how we can able to predict the billing cycle and the behavior of customer consumption, and so on, right? So anyone has any questions?
So what is full form of HEES?
So you are asking this, HEPS?
HES.
Huh. Head end system.
Right.
So a head end system is the main server. So think about like the main server, okay? So where we are hosting any of the system, it could be the SCADA system or analytical system, all these data which we have collected, right? So this will be fed to the head end system. So this is what architecture is. Okay, is it clear?
Okay, sir. Thank you.
Okay, yeah. So coming to the key component, okay, the actuators. Okay, so if you see, have you ever been to any of the substation? Who has been to the substation previously? Anyone who has been to the substations? KPTCL substation or MESCOM, BESCOM, any of the power plant?
Yes, sir. Power generation substations.
Okay, great. So ಅಲ್ಲಿ ನೀವೇನ್ ನೋಡಿದ್ರಿ, ಲೈಕ್ ಹ್ಯಾವ್ ಯು ಸೀನ್ the circuit breakers, ಅದೆಲ್ಲ ನೋಡಿದ್ರಾ?
Yes, sir. Transformers, circuit breakers,
Okay,
insulators,
great,
cross arms.
great. ನೀವು ಅಲ್ಲಿ there will be one system called control unit ಒಳಗಡೆ ಹೋಗಿದ್ರಾ?
ಎಸ್ ಸರ್, ಇದು ಬ್ಯಾಟ್ರಿ ಪ್ಯಾಕ್ ಎಲ್ಲ ಇದು ಮಾಡಿ ಅಡ್ಜಸ್ಟ್ ಮಾಡಿರ್ತಾರೆ.
ಓಕೆ, ಅಲ್ಲಿ ಸ್ಕ್ಯಾಡಾ ಸಿಸ್ಟಮ್ಸ್ ಏನಾರು ಇತ್ತಾ ನೀವು ವಿಸಿಟ್ ಮಾಡಿದಾಗ?
ಆ, ಅಷ್ಟೊಂದು ಗೊತ್ತಿಲ್ಲ ಸರ್, ಜಸ್ಟ್ ಐ ವಿಲ್
ಓಕೆ,
ಸಿ.
ನೋ ಇಶ್ಯೂಸ್. ಸೊ ವೆನ್ ಯು ವೆಂಟ್ ಇನ್ಸೈಡ್ ದಟ್ ಕಂಟ್ರೋಲ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲ, ಸೊ ನೀವೇನೇನು ನೋಡಿದ್ರಿ ವೆರಿ ಹೈ ಲೆವೆಲ್? ಸೊ ವಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಯು ಸಾ?
11 kV lines and the
ಓಕೆ,
66 kV
ಓಕೆ. ಸೊ
transmission line.
ಹಾ, ಓಕೆ. ದೆನ್ ಹೌ ದೇ ವೇರ್ ಮ್ಯಾನೇಜಿಂಗ್ ಇಟ್, ಲೈಕ್ ಸರ್ಕಿಟ್ ಅನ್ನು ಹೇಗೆ ಆನ್ ಆಫ್ ಮಾಡ್ತಾ ಇದ್ರು? ಎನಿ ಐಡಿಯಾ?
Opening or closing from switches by using circuit breakers.
ಓಕೆ, ಇಟ್ಸ್ ಅನ್ ಮ್ಯಾನ್ಯುವಲ್ ಇತ್ತಾ ಅಥವಾ ಎವ್ರಿಥಿಂಗ್ ವಾಸ್ ಆಟೋಮೇಟೆಡ್? ಹೇಗಿತ್ತು ಅದು?
Uh, Automated.
Automated, huh? Good,
Yes.
good. Okay, thank you. And anybody else like who has visited the substations? Salman, Rashmi, Mamta, others? ಯಾರು ವಿಸಿಟ್ ಮಾಡಿಲ್ವಾ ಸಬ್ಸ್ಟೇಷನ್ಸ್? ಶಿವರಾಜ್, ಸ್ನೇಹ, ಪವನ್?
ಮಾಡಿದ್ದೇವೆ ಸರ್, ವಿಸಿಟ್ ಮಾಡಿದ್ದೇವೆ.
ಹೌದಾ? ಓಕೆ. ಸೊ ನೀವು ವಿಸಿಟ್ ಮಾಡಿದಾಗ ಲೈಕ್ ಡಿಡ್ ಯು ಸಿ ಎನಿ ಆಟೋಮೇಷನ್ ಹ್ಯಾಪನಿಂಗ್ ಅಥವಾ ಹೇಗೆ?
ಯಾ ಸರ್, ದೇ ಆರ್ ಯೂಸಿಂಗ್ ಸ್ಕ್ಯಾಡಾ ಸಿಸ್ಟಮ್ ಫಾರ್ ಕಂಟ್ರೋಲಿಂಗ್ ಸರ್.
ಓ ನೈಸ್. ಅಲ್ಲಿ ನಿಮಗೆ ಏನಾದ್ರು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡಿದ್ರಾ ಹೌ ದ ಸ್ಕ್ಯಾಡಾ ಸಿಸ್ಟಮ್ ಈಸ್ ವರ್ಕಿಂಗ್ ಕರೆಂಟ್ಲಿ ಅಥವಾ ಹೇಗೆ ಅಂತ ಏನಾದ್ರು?
ಸಿಂಕ್ರನೈಸಿಂಗ್, ಜನರೇಟಿಂಗ್ ಅಂಡ್ ಲೋಡ್ ಸೈಡ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಸರ್.
ಓಕೆ,
ರಿಯಾಕ್ಟಿವ್ ಪವರ್, ಆಕ್ಟಿವ್ ಪವರ್, ಬ್ಯಾಲೆನ್ಸಿಂಗ್.
ಹಾ, ಗ್ರೇಟ್. ಓಕೆ. ಅದು ಸ್ಮಾರ್ಟ್ ಮೀಟರ್ಸ್ ಬಗ್ಗೆ ಏನಾದ್ರು ಹೇಳಿದ್ರಾ?
ನೋ ಸರ್.
ಓಕೆ. ಸೊ ನೀವಲ್ಲಿ ವೆನ್ ಯು ವಿಸಿಟೆಡ್ ಸ್ಕ್ಯಾಡಾ ಸಿಸ್ಟಮ್ ಅಲ್ಲ, ಸೊ ಅಲ್ಲಿ ಅವರು ಒಂದು ಸಿಸ್ಟಮ್ ಮಾನಿಟರ್ ಇರುತ್ತೆ ಆ್ಯಂಡ್ ಕಂಪ್ಯೂಟರ್ ಇರುತ್ತೆ, ಅದರೊಳಗಡೆ ನಿಮಗೆ ಆರ್ಕಿಟೆಕ್ಚರ್ ಏನಾದ್ರು ತೋರಿಸಿದ್ರ ಬೈ ಎನಿ ಚಾನ್ಸ್ ಅವರು ಹೇಗೆ ವರ್ಕ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳಿ?
ನೋ ಸರ್, ದೇ ಆರ್ ನಾಟ್ ಶೋಯಿಂಗ್.
ಜಸ್ಟ್ ಬರೀ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದ್ರ ಅಷ್ಟೇನಾ?
Uh,
ಓಕೆ, ನೋ ಇಶ್ಯೂಸ್. ಓಕೆ, ಎನಿಬಡಿ ಎಲ್ಸ್? ಎನಿವನ್? ಓಕೆ, yeah. So let's talk about the actuators. Okay, so let's say uh, we spoke about digitalization, correct, and we spoke about how smart we can able to turn the legacy device into the newer one, right? So now the actuators, these are the very key components. So what these actuators will be doing is, so these have the intelligence to close or open the system. And let's say we have a circuit breaker, right? So circuit breaker is used for the fault isolation. If some fault happens, we have to break that circuit to reduce the further uh, the issues, right? So how do we do that? So these are all the actuators. So basically what these actuators will be doing is, let's say if so these actuators will be intelligent in such a way that it can able to automatically detect the fault and do the isolations. So we will be feeding the input, the control circuits, we call it as a control circuit. So based on this control circuit, this will be able to take a decision whether to open or the close this system, right? And also the voltage and reactive power control. For example, for the reactive power we will be having the capacitor banks, right? So higher the reactive power, it is not good for the system. We have to keep on compensating the reactive power so that we will be having the good quality of power. For that we have the capacitor banks which is stationed in all the substations where we will be pumping the reactive power uh, into the system, right? So based on that also these actuators take the decisions. and the third point is the load balancing. So these are helpful in the load balancing. So let's say if you want to increase the load or decrease the load, so these actuators, right, so these actuators plays a very key important role in the substations, right. So I was mentioning earlier, right, reactive power control. So if you go to the any of the substation or any of generation units, right, they will be having the inverters. So these inverters are like just to pump the reactive powers. So when you have these actuators, right, what is the operational impact? So coming to the operational impact, it helps in the self healing, automated fault tolerance, voltage and reactive power control. And when we have this self healing and stability, automatically the efficiency will increase. That is the dynamic load balancing, right. This is the key component in the smart grids, right. If we don't have these kind of decision making of cutting the circuit on or off and increase the load based on the demands, so we cannot able to do this, right. So this is all about physical grid actions. Now, so the characteristics, and we spoke about we have the coal, we have hydro, and we have nuclear power station, right. Those are all kind of stable generation, so we can able to predict the output. But when it comes to the renewable, right, so let's say we have solar PV cells, and we also have the wind, the hydro, fine, we can able to do the prediction. And the biomass, so these are all the kind of renewable resources where there is a little challenges. Let's say in the solar PV, it's like intermittent, like from the morning to evening only we get the output, and the impact is like the massive amount of voltage fluctuation, right. We will not have the stable output from the solar PV cells. So it can be unvarying, it can go up or else it can go down. The similar way for the wind also, it is, even though we get the wind 24 by 7, but it is not that consistent, right. The frequency instability is very much high in the wind. So because of this, there will be an higher impact on the grid, right. And the hydro, yes, it is flexible, we can able to stop and generate the uh, resource, and we can able to utilize this hydro to match the peak load balancing. Let's say for example in the early morning start of the day, or else like in the afternoon, where there is a high demand, so where we cannot able to match through other sources, right. So hydro, so what they will do is they will increase the production and the pump the power into the grid, so that we can able to match the load balancing, right. And the biomass, it is, even though it is like a very smaller one, but it is not that great. We cannot able to rely on the biomass to have the impact, and we cannot able to rely on this to have the demand meeting, right. So these are all the little challenges what we have in the renewable resources. So this is one thing. And also why because these are all the challenges, like so this is the reason we are trying to do the smart grids, where we can able to improve the variable generations, we can able to reverse the power flow, and also we can able to increase the higher penetration of DERs. So when we enable these, so real time monitoring we can able to enable by using the smart grids, the dynamic voltage and the frequency control, the forecast based dispatches, so everything can be achieved. And these challenges where we have it in the renewable can able to mitigate it, right. These are all about the challenges now. Yeah. So we'll do one thing. So let's take an the break for 20 minutes. Okay, we'll have our breakfast and we'll come back. Is that okay? And we'll continue later. Is that fine?
Yes, sir. Yeah.
Yeah, we'll have a breakfast break for 20 minutes and we will come back. Okay, thank you.